Good afternoon, my YouTube viewers. In this particular video, what we're going to do is we're going to calculate the confidence intervals for house prices. And a person wants to explore the price of single-person houses. So we're going to write a program in Python to explore these house prices, and then we're going to import some libraries that we're going to need to execute the program. So the first library that we're going to import is NumPy as NP. NumPy is a numerical library that makes numerical computations. It creates NumPy arrays, and it even makes distributions. And then we're going to import scipy.stats as stats. So scipy is Python's scientific library. Stats is a statistical module in scipy. And stats is the, what we're going to call it. So we're going to calculate, we're going to define the variable house size, which is a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 house sizes. And then we're going to calculate, or we're going to define the house price, which is a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 house prices. And then so we're going to set our house price data, which we've already done the house price data, and then we're going to calculate the mean of the house prices. So mean price equals np.mean house price. Then we're going to calculate the standard error of mean. That's SEM. SEM equals stats.SEM house price. So stats has a function called SEM in it where you can calculate standard errors. And then we're going to determine the t-score for the 95% confidence interval with n-1 degrees of freedom. And so n is 11. Because n is the number of elements in the list. So n-1 is going to be 10. So your confidence level is 0.95. Your alpha, which is also your significance level, is 0.5. Your degree of freedom is the length of the house price minus 1, so that's going to be 10. And your t-score is stats.t.ppf. That ppf means percentage point function, brackets 1 minus alpha, so that's 1 minus 0.05 divided by 2, comma, degrees of freedom. So 1 minus alpha is 1 minus 0.05. So that's 0.95 divided by 2. And so that's going to be, I think it's going to be 47.95, or 40, I think that's what it's going to be, 47.5. So we're going to calculate the margin of error. Margin of error equals t-score times the standard error. And then we're going to conduct the confidence interval. So the confidence interval equals your mean price minus your margin of error, comma, mean price plus margin of error. So we're going to print the mean house price. We're going to print the standard error of the mean. We're going to print the t-score for a 95% confidence interval. We're going to print the margin of error. And we're going to print the 95% confidence interval for houses, your confidence interval. So your mean house price is 254.36. Your standard error of the mean is 48.74. Your t-score for a 95% confidence interval is 2.23. Your margin of error is 108.61. And your 95% confidence interval for house prices is 145 108.76 to 362.97, because you take your mean house price and you add your margin of error to it. So it's going to be, which is 108.61, and that's why it's going to give you the 145 to the 362. So that is the exploring the house prices. So now what we're going to do in the next video, we're going to talk about house sizes, and I hope that you decide to watch that video.